Welcome to CSC 121. It's programming in C++ for beginners. Okay, so the first question we really have to answer is, what is a computer? You've all used them. They are desktops, laptops, tablets, cell phones, cars, washing machines, all that. They're everywhere. They're embedded in almost everything we do in society now. But what really is a computer? Well, it's a machine consisting of the following components at a minimum. A CPU or central processing unit, which is where all the math, logic, and instructions such as that happen. A primary storage area, which can consist of two parts. RAM, which is random access memory, and that's volatile memory that can be changed, but when the power goes off, it disappears. ROM is read-only memory. That's stuff fixed in a specific type of memory that cannot be changed or altered, just read. Now, this isn't nearly enough for a modern computer. It doesn't talk about networking, it doesn't talk about input and output, the screen, the printer, etc., but we'll get into more details about that. So let's talk about what's important. What is a CPU? The CPU is the heart of the computer. It can do the following operations. Program control. In other words, it tells what instructions to execute next. Arithmetic, add, subtract, multiply, divide, logical expressions, and data movement, moving data around so programs can use it from one part of memory to another, or from memory potentially to a hard drive. Here's a good example of what it looks like. This is an Intel chip, and in the front you'll have the thing, and here you have literally, probably 500, probably 1,000 pins, and that's how it connects to the computer's bus. Primary storage consists of two things. ROM, which is used to store things that remain forever. Bootloaders for an operation system, how a computer knows how to start Windows, for example, are good examples of what's kept in ROM. RAM, on the other hand, is volatile. It can hold both programs and data, but it loses its contents when the power is turned off. RAM memory sticks, like you might have seen, these are good examples of RAM. So what is memory? Memory is where a computer stores data and programs. Think of it as a bunch of numbered mailboxes. We've got address 1, address 2, address 3, address 4, and so forth. They're all connected. Each box can store a value. On modern day processors, this value is typically 64 bits long, and we'll talk about what a bit is later. But we can address any of them. I can say, tell me what's stored in mailbox number 5. In computer terms, we'd say, tell me what's stored in memory address number 5. A bit in memory is a single piece of information with the value 0 or 1, and it's usually mapped in base 2. That's it. It can either be a 0 or a 1, on and off. Now, there are new advances like quantum computing, which mess with this, but that's not within the earliest scope of this class. So, in base 2, 0 equals 0, 1 equals 1, but 2 equals 10 in binary, 3 equals 11 in binary, 4 equals 100 in binary. So a byte, which is 8 bits, can have 2 to the 8th values, or up to 255 values. A word, 256 technically. A word is made up of bytes. A byte is 8 bits. A 64-bit word can be thought of, therefore, as a 4-byte word. 64 bits are referred to as a 64-bit word. Older computers use 32, 16, and 8-bit words. 2 bytes gives the amount of values you can represent at 65,536 values. 4 bytes can give you well over 18 trillion values. So there's a lot there in 4 bytes. Just doubling the number of bytes can give you considerably more possibilities. How do we put it together? Well, there's a motherboard. A motherboard is a container that contains the memory, the CPU, and other hardware. Okay, so here we've got the memory socket. These are where the memory is stored. And we've got the CPU, which is where we put the actual data cruncher. Other important ideas. Components of the motherboard are connected. The connecting lines between them are called a bus. There are several buses in typical desktop computers for video, for other memory. The standard computer architecture of this style is called a von Neumann architecture. It's named after Dr. John von Neumann, who was one of the early originators of the computer. So there are different types of buses. Let's talk about a few. We've got memory or internal buses. This connects the internal components, such as memory and the CPU, to the other motherboard components. There's an address bus. This specifies the address of memory to read or write, and it is also used to implement ideas like a virtual memory. The control bus is used to communicate with other devices like networking cards, hard drives, or printers. So how does a computer does it work? At its heart, a computer does its work by following a machine or fetch-execute cycle. So step one is it fetches the next instruction from either a cache, which is smaller storage, or memory, RAM. The instructions are decoded into a form the arithmetic logic unit or floating point unit can understand. We separate the two because we don't handle integer arithmetic the same way we do floating point arithmetic. Then the instructions are executed on the CPU. It carries them out. And then we store the results in registers, which are parts of the CPU, or in RAM. So what's an operating system? An operating system is the software the computer uses to control its basic functions. It schedules tasks, so you can have multiple programs at once. You can execute applications, and it controls interaction with peripherals. Windows, Linux, iOS, Mac OS, Android, and whatever controls your TV, for example, the Roku OS. What is a computer program then? A computer program is an expression of an algorithm plus its associated data expressed in a manner the computer can, quote-unquote, understand. An algorithm is a finite sequence of steps for solving a problem. It ends. The key thing to notice is the word finite. To be considered an algorithm, the process must terminate. If it's not, it's not technically an algorithm. A program is a very, very detailed sequence of steps to solve a problem. Okay, and these are expressed by people in what's called a programming language. At the lowest level, a program is an extremely detailed set of instructions called machine language, ones and zeros. Machine language is incredibly primitive and consists of very simple instructions such as fetch a value from memory, write a value to memory, compare two values, subtract two values, or go to a different part of the program. Very detailed programming and very hard to get right. So what we did next is we came up with assembly language. Instead of saying 1001, we moved to a mnemonic language where we, instead of saying 10001, we say load register 1 with the value from memory at location 6. And then we say load register 1 from register 2, register 2 from register 1 with the value 0, and so forth. Still not exactly what I call easy to understand. This would convert it, however, to machine language, which looks much more like this. Higher level language, such as assembly and machine languages, are impractical for large programs. It's just almost impossible to understand. If we had a very simple piece of C++ code that multiplied two numbers, this is what it looks like in assembly. That's a lot of work to understand. Higher level languages are notations for expressing algorithms in more friendly fashions. Some of the more popular notations are C++, Java, C#, JavaScript, PHP, Ruby, Python, Basic, C, Rust. There's many others. My favorite language is C#. To be 100% honest, I am not a huge fan of C++. I think it's outdated and a bit clunky. So how do we translate from a high-level language? The computers can only run machine language, so something must translate our high-level language to something lower level. There are two ways to do this. One is called a compiler, and one is called an interpreter. A compiler takes a high-level language and translates it to either a machine language or what's called an intermediate language. C++ runs through a compiler and produces intermediate or machine language. Intermediate language is just an intermediate step to allow us to do more interesting things. And intermediate language is used, for example, by C# and Java. And the main reason you'd use that would be to make it portable, because if you have an intermediate language, you can just create an interpreter for that intermediate language and use it on another computer. An interpreter, it takes a high-level language and actually executes it. It actually walks through the program. It doesn't interpret it. Interpreters are like somebody who, as you say the words, interpreters. Translators or compilers are somebody who you give them a book, they convert the book from English to Spanish, and then they're done. Net and Java combine both compiling and interpreting. That's C# and Java. They generate an intermediate language which is then interpreted on the client. As it's interpreted, however, it's also compiled. JavaScript is also interpreted. PHP and Ruby are also interpreted. The biggest disadvantage of interpreters is speed. It's slower to interpret code. So what is an algorithm? An algorithm is a step-by-step solution to a problem which must always terminate. Okay? For an algorithm to be programmable on a computer, it must also be deterministic. The same inputs must produce the same outputs. A deterministic algorithm is an algorithm which, given a particular, will always produce the same output, with the underlying machine always processing code the same way. Each step must be unambiguous in its intent, or else it won't translate into a computer language easily. Computers don't do well with ambiguity. Let's take a very simple algorithm of how to make coffee. Our first step is we start. First step would be boil some water, get a mug, put a teaspoon of coffee in the cup, put a teaspoon of sugar in the cup. While the water is not boiling, wait 1 minute, check again. Wait 1 minute, check again. Wait 1 minute, check again. Finally, when we're done, we pour the water into a mug, we stir, and then our process of making coffee is done. The next process might be drinking coffee. So, let's give it our algorithm. Does it always terminate? How do we boil water? What happens if the water never boils? If that happens, the algorithm doesn't terminate. So our algorithm isn't a perfect algorithm. Okay, but it is impossible to write a program that tells you if another program arbitrarily terminates. That is actually called the halting problem in computer science. It's a very big and research-oriented problem. So what is C++? C++ is a programming language based on a prior language called C. It adds what are called object-oriented features to the C language. And those features give you a different way of programming. C++ is the parent language of modern languages like C# and Java. C++ is mostly used for low-level programming. It was created by Bjarne Stroustrup in 1979, and it was originally referred to as C with classes. So, let's write our first C program. Here's the simplest program you can have. Okay, this program does absolutely nothing, but it illustrates some important points. This is our program entry point. Every single program in C++ must have a program entry point. Here is the return type. Every single program in C++, not every single, most programs in C++ return a value. Here, inside these squigglies, is the program body. Here is where the program will actually execute. Okay, so every program must have a starting point and it must be called main. There are several flavors of main. There's void main. This is the simplest form. Older compilers don't like this, however, but much older. Main int argc, argv takes a number of parameters indicated by argc and their values. We'll talk about this later. Main is a function. It's similar to a mathematical function. A function is a set of named instructions, such as a single unit. A function may have parameters, which are pieces of data sent to the function, and they return a value. So basically, consider math. You've got f of x maps to some set of results, and with computer functions, f of x returns a set of results, or a value, typically. In C++, you insert your code by including it. Include statements tell the compiler to include another file's contents. Pound include statements are what are used in C++, and they're called preprocessor statements. They're actually not part of the language. There are two different types of includes. There's include with brackets, which includes a standard head filer that's part of C++. For example, include studio or IOStream. Pound include with quotes is a particular part of your project. And it allows you to use standard input and output functions from Studio. In C++, we have the concept of a stream. A stream is input and output A stream is literally a stream of characters or bytes. A stream can be one of many types: a file stream, a console stream, a network stream. Two of the most common streams we'll talk about are cout and cin. Those are the names. Cin, console in, reads data from the keyboard. Cout writes data to the console. How do we display something on the screen? To output to the console, we use the cout standard stream. We'd say there's supposed to be two double arrows. Cout, double arrow, double less than, hello world. You can also use variables in cout and must use them in iOS. How do we read something from the keyboard? Well, we're going to use the getLine function and introduce the concept of a string. A string is a collection of letters, numbers, and words. It's something you might type in the keyboard. So we declare a variable string user because every variable has a type. And then we say getLine from cin, the user. This will place the read in data from the keyboard in the user variable. Think of a variable as a box where you can put data of different types in. How do we report an error? There's a special outbound stream called cerr. Why do we use cerr instead of cout? Cerr is intended to use by errors and could be associated with different streams. For example, a console could be cout and a file for cerr. We put it all together, and here's our very first C program. It inputs a name and then just prints it out. And we'll go over and we'll actually build our own version of it. We're going to take a look at the simplest possible C++ program that does something useful, and it's also traditional. So it's called Hello World, and it's going to print the words Hello World to the screen, and that's it. So what we're first going to do is include the library IOStream. We need this library to do input and output. Without it, we can't. Okay? This next statement is called a using statement. And if we don't have it, we're going to have to type the letters std : in front of almost everything. And it's a real pain. Some C++ programmers don't like to use this, but I am not one of them. So main, as we said before, is the entry point into our program. And every C++ program begins with a main. We're going to return an integer. So, and we're going to use cout here. That's the output stream. And the double arrow is called the insertion operator, which means insert what follows into the output stream. /n is one of two ways of how we use to print a new line. Another way we can use is to use the endl constant, and it's a matter of personal preference. Every statement in C++ that isn't part of a block, which we'll learn about later, has to end with a semicolon. Finally, when we're done, we tell the program to return 0 because we're being a good citizen and telling the operating system our program completed successfully. So now we're going to run this program. Okay. And we're starting our build. And when we run it, we will notice, if we go over to the terminal, that we printed the string, hello world. Yay! So we finished our first program. Congratulations. Now, as before, we're going to start with this. We're going to use this as a template. Here we do our include to get our IOStream, and we use our namespace standard. We've got our same old main, and we return 0 to exit the program. So what's the first thing we're going to do? We are going to declare a string variable, and that string variable is going to hold a name. Okay, but before we use a string, we want to also add another library include to get this functionality for strings by saying this. Okay, so now we'll declare a string. Okay, and we'll put a comment in above it with the double slash. From the keyboard. All right. Then what we're going to do is we're going to put a prompt out because we like to keep things pretty. We'll say cout, please enter your name. Put a colon here to make it look pretty. Notice I'm not doing a new line. I don't want it to go to the next line because I want it to look like the front. And then we'll say is get line, and we will read it from the C input, and it will be stored in the variable name. Okay, so let's put a comment in here saying prompt for the user to enter his name, and now print out the user's name on the screen. All right, so the way we'll do that is count /n, which means we're putting in a new line. Then we're going to string another count right next to it, where we're going to say the name entered was, and then we'll say name, just putting out the contents of the variable, and then we'll say endl. Okay? So now when we're done with this, we'll save our code, and we will run it and see what we get. Okay, please enter my name. And there you go. There's our first program. Okay, and then like before we said, when you're done, come over here to the source control, give it a message, second program, hit commit so it pushes it out there. And now when it's done, we hit Save Changes, and after this, I can grade it. So I hope this gives you a good overview, and we will dig more into it later.